Now, we're going to consider the movement of a mobile particle in the Cartesian plane, and say it follows kind of something, a pattern like that. And at some time, it has for x coordinate x of t, and for y coordinate y of t. Well, this vector here, which I'm going to call r of t, is called the r of t, which is a vector, is called the position vector. And so, okay, at that particular time it's there, and a bit later it's there, and then it's there, and so on. So r of t is made of, okay, so sorry, I should have added the unit vector here, I and j. So I of t is made of two components. There is the x component, which is a function of t, and then t is a time, of course. T is a time. And then there is a y component, which is also a function of t. So t is a time, and it's also called the parameter, because that's from this parameter, from this value t, we can perfectly determine the position of the mobile. Now, sometimes we are able to, I'm just going to write that in full letter. Sometimes we can eliminate t and get a function, or sorry, I should say relation, between y and x, which is called the Cartesian equation of the movement. Well, because in that case we are talking of the movement of mobile. Right, so I think let's do an example. Say we have r of t is given by r of t, so the position vector is given by 1 minus ti plus t square j. So that means that in that case, x of t, the x coordinate is 1 minus t, and y of t is just t square. Okay, so this is a parametric equation. Of the movement. Now, can we get the Cartesian equation? Right. So okay. Sometimes just to abbreviate, instead of noting x of t, it's just noted x, and instead of noting y at t, it's just noted y. So well, so we've got equation 1, equation 2. From equation 1, we can see that t is equal to 1 minus x. So we're going to be substituting this into equation 2. So that means that equation 2, to eliminate the parameter, so that means that equation 2 becomes y is equal to 1 minus x squared. And or if I expand that, I know it's x squared minus 2x plus 1. And we know very well what is the movement of that. It's a parabola. So this, in that case, is a Cartesian equation of the movement. Now, I'm going to do another example with trigonometric function. So say, for example, we have x as a function of t is equal to cosine 2t, and y as a function of t is equal to sine t. So that means that the position vector r of t is equal to cosine 2ti plus sine of tj. Now, okay, so this is a parametric equation because the parameter appears here. Now, can we get the Cartesian equation? Cartesian, okay. So x is equal to cosine 2t. Cosine 2t we know from basically a trigonometric relationship that it's 1 minus 2 sine square t, double angle formula. So therefore it's equal to 1 minus 2y square. So that means that 2y square is equal to 1 minus x, or y square is equal to 1/2 minus x on 2. So that means that y is equal to plus or minus root of 1/2 minus x on 2. And obviously there would be some restrictions of the value of x, which can only take values between minus 1 and 1. And this is the Cartesian equation. It's basically a parabola, but a parabola which is rotated by 90 degrees. That's it.